Hello students, welcome all to my mentor math class. Are you ready students? So let's start the class. Students, today I am going to discuss about L'Hopital rule or L-Hospital rule for evaluating limits. And this rule basically we have to use when the form is rational form, Ex by Qx form, and also the limiting form is 0 by 0 type or infinity by infinity type or minus infinity to infinity by infinity type. Okay, so this is your indeterminate form. Okay, so look at this form is L-Hospital rule or L'Hopital rule for evaluating limits in the form of 0 by 0 or infinity by infinity or minus infinity by infinity. That is your indeterminate form. So first of all, you have to know when this rule actually applicable. Okay, so first condition is the form should be px by qx form. That is your rational form. Form should be rational form, px by qx form. That is your numerator and denominator form. And secondly, obviously the second form is limiting form. Limit, let us take x tends to c, px by qx should be 0 by 0 form, should be 0 by 0 form or infinity by infinity form or minus infinity to infinity form. That is your indeterminate form. So when you put x replaced by c, you see the numerator becomes 0, also denominator becomes 0. That is your 0 by 0 form or infinity by infinity form or minus infinity by infinity form. First two criteria be there, and third criteria is this px by qx both function are differentiable function. So you have to know that is either px and qx both are differentiable or not. Both are differentiable function, both function are differentiable at x equal to c, because x tends to c means at x equal to c you have to check that px and qx both are differentiable function. If not differentiable, then we can't apply this L'Hopital rule or L-Hospital rule for that form. Okay, so first of all, these three criteria, if you see the form satisfy these three criteria, that is your rational form, that is limit extend to c px by qx, that is your 0 by 0 form or q by infinity form or minus infinity by infinity form. And third criteria is both function are differentiable function at x equal to c. If you see that three conditions satisfied, then you can apply your L'Hopital rule or L-Hospital rule for finding or evaluating the limit 0 by 0, infinity by infinity or minus infinity by infinity. That is your indeterminate form. Okay, so basic concept, this is your basic concept for L'Hopital or L-Hospital rule or L'Hopital rule. Okay, so copy please. Okay students, now what is your L'Hopital rule or L-Hospital rule? Okay, so first of all, if you see that limit x tends to c, let us take px by qx, and this form is if this, and this form is your 0 by 0 form or infinity by infinity form or minus infinity by infinity form, then that rule suggests this indeterminate form, this indeterminate form convert to determined form. Okay, so your job is, if you see that this form is given 0 by 0, infinity by infinity, minus infinity by infinity, so this indeterminate form convert to determined form. And how it is possible? You have to take derivative, differentiation with respect to your for your numerator as well as denominator, that is your p dash x by q dash x. Again, if you see that that value gives again 0 by 0 form, if you see after differentiation, if you see that the form again you have 0 by 0 form or infinity by infinity form or minus infinity by infinity form, then again you have to derivative this numerator and also denominator, second time derivative. Okay, so this is continue till this indeterminate form to determined form. If you see the form comes to your determined form, then if you see the form is convert to determined form. That means not 0 by 0 form or infinity by infinity form or minus infinity by infinity form, then stop the process. Stop the process. So this is the basic L'Hospital rule or L'Hopital rule. That is, if you see the quantity is given, limit x tends to c px by qx, and this px and qx both are differentiable function at x equal to c, as well as the form is 0 by 0, infinity by infinity or minus infinity by infinity. This is your indeterminate form. So that rule applicable for indeterminate form convert to your determined form. And how it is possible? We have to derivative numerator as well as denominator, p dash by q dash x, p dash x by q dash x, and again you see that again form is 0 by 0, infinity by infinity, minus infinity by infinity, then again you have to derivative p double dash x by q double dash x. If you see again that form is 0 by 0, infinity by infinity or minus infinity by infinity, again you have to third time you have to take derivative. Okay, and this process continue till it convert to determined form. That means denominator not equal to 0. Okay, if you see denominator not equal to 0 or the form is not 0 by 0 form or infinity by infinity form, that is your determined form. If you see form is determined form, then the process is stop. Okay, so this is the basic concept for L'Hospital rule or L'Hopital rule. Copy please. Okay, next. Now if you solve limiting value of any quantity, and when you apply your L'Hopital rule or L'Hospital rule, so you have to definitely know that some basic differentiation formula or derivative formula you have to know, because this formula basically used for short form. If you use L'Hospital rule or L'Hopital rule, you can easily find the limiting value for 0 by 0 form or infinity by infinity form, and for that solution you have to know the basic formula for differentiation. And this is the basic formula. You can see now some important derivative formula. First formula is ddx of derivative with respect to x of x to the power n is equal to n x to the power n minus 1. Number 2, derivative of x with respect to x is equal to 1. Derivative of constant value is equal to 0. Derivative of exponential e to the power x is equal to e to the power x. Derivative of a to the power x, some constant to the power variable with respect to x, that is your a to the power x log base a. Number 6, now comes to your trigonometric form. ddx of sin x is equal to cos x. ddx of cos x equal to minus sin x. ddx of tan x equal to sec square x. ddx of cosec x equal to minus cosec x into cos x. ddx of sec x equal to sec x into tan x. ddx of cot x equal to minus cosec square x. So this is the basic formula you have to know for apply your L'Hopital rule or L'Hospital rule, because whenever comes to basic example, that time you have to use that formula also. So basic formula you have to know first. Okay, so copy please. Next comes to your one example we can solve. Limit x tends to 0, 1 minus cos x by x square. Okay, so we have to find the limiting value for this quantity. So you can use the L'Hospital rule or L'Hopital rule, because of this is your numerator by denominator form, this is your rational form. Obviously this numerator and denominator both are differentiable function, and if you see that if you put x tends to 0 here, obviously you got 1 minus cos 0 by 0 square. That means what is the value for cos 0? That is your 1, and 0 by 0 form, this is come for 0 by 0 form, means you have to apply, or we can apply your L'Hopital rule or L'Hospital rule. Okay, comes to your solution, that is limit x tends to 0. Now you have to derivative numerator as well as denominator. Comes to your derivative ddx of 1 minus cos x as well as ddx of x square. Okay, so that is limit x tends to 0. Now you know that constant term derivative is 0 minus the derivative of cos x is your minus sin x divide by, and derivative of x square is, that is your 2x. Now you see that this is your 0 by 0 form, this is your 0 by 0 form, you can write here. So now first step is done. Now limit, you got the limit x tends to 0, you can write by L'Hospital rule or L'Hospital rule or L'Hospital rule. You can write limit x tends to here, comes to here, comes here, x tends to 0, minus minus plus sin x by 2x. Now comes to again, if you put again x equal to 0 here, x equal to 0 here, again you got the value sin 0 by 2 into 0, that means again 0 by 0 form. So again if you see the quantity again 0 by 0 form, again you have to differentiate numerator as well as denominator. So you can derivative, that is limit x tends to 0, the derivative of sin x, you know that cos x, derivative of sin x is equal to cos x, and derivative of 2x constant is outside, and derivative of x is 1. So you got the value of limit x tends to 0 cos x by 2. Now you see that this form is not 0 by 0 form or infinity by infinity form. This is your determined or determined form. This is your determined form. You see that using your L'Hospital rule, this indeterminate form convert to your determined form. That is stop the process, and now your job is you have to substitute the value x equal to 0 here. So next copy please. Now you see that the expression becomes limit x tends to 0 cos x by 2, and if you substitute here cos 0, that is x replaced by 0, you got cos 0 by 2, and the value of cos 0 is 1, so 1 by 2. So this is your finite and this is your solution, limiting value of this function. So in that way we can solve this type of problem, and you can apply this L'Hospital rule or L'Hospital rule. Okay, copy please. Next, another problem is limit x tends to 0 e to the power x minus 1 by x square. So we have to find the limiting value of this expression. Now obviously this expression is your px by qx form, that is your rational form, numerator by denominator form. And you see that if you substitute here x by 0, you see that the value is e to the power 0 minus 1 by 0 square. That means something to the power 0 is 1, minus 0 minus 1 by 0, that means obviously 0 by 0 form. And this quantity is represent 0 by 0 form, as well as this is your rational form, as well as numerator is your differentiable function, as well as denominator is your differentiable function, so that you can apply your L'Hospital rule or L'Hospital rule for finding this limiting value. Okay, so now comes to your solution, that is limit x tends to 0. We have to derivative your numerator. So you know that derivative of e to the power x is e to the power x minus derivative of x is your 1 minus derivative of constant term is your 0. Divide by, you know that derivative of x square is your 2x. Okay, so now you got your limit, and this is your obviously 0 by 0 form, you can write here. That is now comes to here x tends to 0 e to the power x minus 1 by 2x. Again, if you substitute x by 0 and x by 0 here, you got the value e to the power 0 minus 1 by 2 into 0, that is 1 minus 1 by 0, that is 0 by 0 form. So if you see that again the quantity is 0 by 0 form, so again we have to apply your L'Hospital rule. Again derivative, numerator and denominator we have to do. Okay, so again we have to apply L'Hospital rule, that is limit x tends to 0, numerator derivative, denominator derivative. So we have to differentiate this numerator. So e to the power x derivative is e to the power x minus constant term derivative is 0 by 2x derivative is 2 into 1. So finally you got limit x tends to 0 e to the power x by 2. Why it comes or how it comes? Actually differentiate. Look at this, differentiate. E to the power x derivative is e to the power x, constant derivative is 0 and 2x derivative is 2. So why? Because this is your 0 by 0 form. This is your indeterminate form. Indeterminate form convert to your determined form using your L'Hospital rule, that is your differentiate numerator as well as denominator. Okay, so now comes to your x tends to 0 e to the power x by 2, and if you put here x by 0, you get the e to the power 0 by 2, and that value is 1 by 2. That is your solution, that is your 1 by 2, because if you substitute 0 here, Now e to the power 0 by 2, and this form is not 0 by 0 form. This is your determinant form that is stop the process, and you can put here x by 0. So e to the power 0 by 2 is your 1 by 2. So then in that way you can solve this type of problem, and using your L'Hopital rule, if you see that quantity or condition is satisfied. If the form is satisfied, these three conditions, then you can apply your L'Hopital rule. And for that, basically L'Hopital rule, basically you have to know, if you use L'Hopital rule, you have to know about your derivative formula, important derivative formula, and then apply, and you can easily solve, you can easily find the limiting value of the any quantity. Okay, so copy please, and next class again we will discuss. Okay, thank you.